Assalamualaikum and good day to everyone. First of all, let me introduce myself and my teammates. My name is Nashaira Hanis binti Roslan and my teammates Muhammad Hafizi bin Halim and Shazrin Effendi bin Ghazali from Group 4. Now, we would like to present our assignment entitled A Hydraulic Pump Gear. Okay, first of all, let me introduce what is a gear pump. A gear pump uses the meshing of gears to pump fluid by displacement. Gear pumps are also widely used in chemical installation to pump high viscosity fluids. Gear pumps are positive displacement or fixed displacement, meaning they pump a constant amount of fluid for each revolution. Then, an external precision gear pump is usually limited to a maximum working pressure of 210 bars, which is 21,000 kPa, and a maximum speed of 3,000 rpm. There are two main variations of gear pumps, which is external gear pumps, which use two external spur gears, and for internal gear pumps, which use an external and internal spur gear. Then the application of the gear are followed as petrochemicals, which is pure and filled bitumen, pitch, diesel oil, crude oil, lube oil, and so on. Then for the chemicals, which is sodium silicate, acids, plastics, mixed chemicals, isocyanates, and so on. Next, paint and ink, resins and adhesive. For the pulp and paper, which is acid, soap, lye, black lacquer, kaolin, lime, latex, sludge, and many more. Lastly, for food, which is chocolate, cocoa butter, fillers, sugar, vegetable fats and oil, molasses, and animal foods.
This is the bill of material for our product, which is gear pump. It consists of 15 parts, which are the main body, lock sleeve, small pin, housing seal, idle gear, drive shaft, sleeve, big pin, housing, fastener screw, nipple part, drive bed plate, and oil seal. This is the exploded view of gear pump. Next, these are the elements of hydraulic gear pump. We choose three elements, which are drive shaft, fastener screw, and idle gear. First, the drive shaft is a pump drive shaft which rotates the mechanism, extends slightly beyond the mounting base through the pump housing. By means of a drive coupling, torque from the driving unit is delivered to the pump drive shaft. Second, a fastener screw is a hardware device that mechanically connects or affixes two or more things together. Lastly, the idle gear is an internal gear pump is the driven gear, rotated by the rotor which is the driver gear.
Now it's my turn to explain about the FEA analysis, which is to identify the failure of the gear, which is ideal gear. This is the type of the failure of the gear. Number one is the missing tooth gear, and number two is the chip tooth gear, and last one is the worn tooth gear. As you can see at the figure shows, this is because considering the manufacture involved in gear material, design, manufacture, and also service life, the ability to properly assess a gear failure is a valuable tool in identifying the root cause of the problem and implementing corrective action to prevent early failure or to extend the gear life. So for this failure, we only focus on the tooth bending fatigue, which is the most common mode of failure in gearing and result from cracking under repeated stress below the ultimate tensile stress of the gear. The fatigue life also can be extended by maximizing the ultimate tensile strength of the material. Next is maximizing the residual compressive stress in a case also improve the fatigue life. And the last one, this is also can be achieved by using a low carbon content and by short cleaning after heat treatment. So for this 4 points, we only focus for the material of the gear, which is can reduce the cracking of the gear. Now for the FEA analysis of the tooth bending fatigue, for the original design, we choose the material which is alloy cast steel, and the tensile strength is 448 Newton millimeter square. As you can see, the result is the von Mises of the stress of the gear, which is 39.6 megapascal, which is higher. And for the displacement is 0.00304 millimeter, and the last one is for the strain is 0.000141. This is the original design of the gear before improvement. So for the redesign gear, which is we only change the material of the gear, which is ISI 304, which is the tensile strength is more higher than the alloy cast steel, which is 517 Newton millimeter square. So the result for the FEA analysis, we can see the stress or the von Mises is only 38.8 megapascal. Continue with the displacement of the gear, which is a 0.00303. The last one is the strain, which is the value of 0.00143. So the result for the by changing the material of the gear, we can see a difference between the value of the stress, the displacement, and also the strain.
After done to redesign the gear, we can conclude that by using the FEA analysis, we can avoid the failure from occur in the system. It is important to us to understand the function of using the finite element analysis and apply to daily life for a better future. I think that's all from us. Thank you.